So we have tonight Dr. Chelsea Harms-Tuohy and his husband, PhD candidate Evan Tuohy. They're from the Isla Mar Research Expeditions. Isla Mar is a marine science research and education company that performs independent scientific research around the island, focusing on coral reefs and fish communities, including coral reef restoration. The company also implements marine conservation-related outreach and hosts field courses for graduate and subgraduate students, where they learn how to be field-based marine scientists. A little information about Dr. Chelsea and Evan. Chelsea was born in Texas, and she moved to Puerto Rico to pursue her doctorate. She earned her PhD in biological oceanography from the University of Puerto Rico in Mayagüez in 2016. Evan was born in Florida and is currently finishing his PhD in biological oceanography from UPR Mayagüez as well. The couple met in Puerto Rico during a field course with their alma mater Florida Tech in 2008, and moved here permanently in 2011. While still in graduate school, they started Isla Mar Research Expeditions in 2015 to pursue their passion for teaching in a non-traditional setting through hands-on field courses for visiting students. Since then, they have expanded their company to provide educational workshops and training to local volunteers and students, offer dive-related project assistance as scientific divers and with their 30-feet dive boat, and they also conduct their own research on fisheries-related topics funded by federal and state-level agencies. In June, they added a new member to their team when they welcomed their first child, Jack Fisher Tuohy. So I'm gonna let Dr. Chelsea start the presentation, and thanks for being here tonight with us.
Awesome, thank you, Carla. I appreciate it. Thank you for the introduction, and thank you everybody for joining us on this call. It's my pleasure to be able to present to you the project that we're working on that's being sponsored by Medalla Light. As I'm sure many of you have probably already seen the video, so you might have heard a little bit about what's going on. So I'll be able to talk to you a little bit more about it in depth. So I'm going to present this in English, but the slides will be in Spanish. So hopefully that'll be a nice marriage of both languages here for us. So let me advance the slide. Okay. Carla did a great job explaining who we are. So I'm just going to kind of elaborate on that just a little bit so that you know a little bit more about us and about our colleagues that are working on this project. So as she mentioned, we are Isla Mar Research Expeditions. It's myself and my husband, but we also have a team of contractors that work with us on various different projects. We usually have 3 to 4 different projects that we have going on at the same time. So there's never a dull moment. We always have something fun that we're working on. We are primarily fisheries and fisheries management based, and we operate mostly on the west and the southwest coasts. HDR Reefscaping is our partner in this particular project. The executive director of Reefscaping is Dr. Hector Ruiz, and Carla mentioned that you guys had a charla from him last year, so you know a little bit about Reefscaping. But as it relates to this project, Hector has 2 decades of experience working in coral reef restoration here on the island, and he's also developed and maintained coral nurseries that are along the south coast. His primary work in reefscaping is through environmental consulting. But one thing that I want to point out about us and about reefscaping that's kind of sets us apart or makes us a little bit different from other scientists in this field is that we are independent biologists. So we're not employees of DRNA, we're not employees of NOAA, we aren't professors at a university. We are strictly independent biologists that write grant proposals to get funding from typically federal or state level agencies, and that's how we fund the research that we do. This case for this project is a little bit different though, which is kind of a new and exciting venture for all of us. And it really started by us sitting down and kind of asking this question of, can we come up with some kind of a solution for the glass waste that we have on the island and the absence of recycling? Because as I'm sure everybody is aware, once China kind of closed off accepting recycling from the United States, then we really no longer had anywhere to send that. And so we're having to deal with that in whatever way that we can here on the island. And the idea for using the glass bottles arose when Evan and I had seen a video shared on social media by a company in New Zealand called Expedition. And this company had created a machine that crushed glass bottles and turned it into sand. And in this particular, in what this company had created, they had this machine set up on the street. And so people could just go to this machine, they'd put their glass bottles in, and they'd get to watch it get crushed into sand. And so we thought this was a pretty clever idea. And, you know, one thing about being independent biologists is that we have a lot of flexibility to write grants and to come up with creative ideas for our field in science. And so this helped us kind of pose the question, well, how could we potentially use this glass sand? And so that's kind of the concept of it. We had, you know, two ways that we wanted to approach this. One was to try to resolve this problem of this waste that we have in Puerto Rico. Like, how can we reduce the possibility that these glass bottles will even, you know, be discarded in the ocean? Like, how can we prevent that from happening? And also, how can we reduce the volume of this glass waste in our landfills? As some people may or may not be aware, but after Hurricane Maria, several of the landfills around the island had closed. And so now I believe we're only left with 18 that are active. So, you know, we still are producing relatively the same amount of waste that we were before the hurricane. And yet we have a much smaller number of landfills to actually accept that waste. And then the second thing is we wanted to introduce, or see if we could introduce, a new material into coral reef restoration. And the idea here would be to minimize the amount of cement that we need, which would reduce our costs. And it would allow us to use a product that had natural minerals that the corals are also using. And I'll explain those things as we move forward. So this posed our foundation for our pilot project. And the question was, can we use recycled glass sand, or what I'm going to refer to through the rest of the PowerPoint as RGS, in coral reef restoration without like hindering the ability of the coral to grow and without altering the integrity of the cement as an adhesive? And what's really interesting about this particular pilot project is that it's sponsored by Medalla. So if you haven't seen the videos that they have put out, please visit our Facebook. We've shared all three of them. There was a series of 3 that kind of explained the campaign that they're helping us promote, with our beaches being like our responsibility and our pride, and therefore our reason to want to protect coral reefs. So when we approached them about helping us with this project, it really became this pretty incredible opportunity for us to reach a much wider audience with this story about the importance of coral reefs and the importance of conserving them. So that was a new venture for us. We had never reached out to a business in this way to ask for financial support with a scientific project before. So we're hoping that this will continue. Now, before I really get into like the details of the project, I want to make sure that we're all on the same page when you hear me talking about corals and restoration. So just to make sure that we all are, you know, understanding as we move forward, corals create their skeletons using minerals like silica and calcium carbonate. So they're actually living animals, like what you see on the right. They are small animals that have soft bodies. That's like the top image that you see. But when those small corals, when those polyps start to grow together, they create a colony. And then as those colonies grow, they create what we refer to as the actual coral reef. So the coral reef is not just one coral, it's many corals. Now, when we say that we have to restore coral reefs, that typically involves planting small fragments of corals in areas where the reefs have been destroyed or where they have been degraded. And a lot of times this involves planting corals that have been grown in a coral nursery, or by carefully breaking a piece of coral from an adult coral and planting that. Sometimes we can even use pieces of corals that have been broken from like natural disasters. For instance, like after Hurricane Maria, we did many coral scientists did restoration all around the island. But like our team focused a lot on the Tres Palmas Marine Reserve in Rincon, where we planted over 1,000 coral fragments. We didn't have to get any of those fragments from a nursery. All of those came just straight from corals that had been broken or tumbled after the storm and after the swell that we had in March of 2018. But we can really only do this with a couple species of corals. So the one you see in the bottom right is the Elkhorn Coral. That one has a natural ability to, when its branches break, they can re-cement themselves to the bottom and continue to grow. And that's actually a reproductive strategy for this coral. So we can take that particular species and perform coral reef restoration by taking those fragments and planting them back to the reef. Now, I mentioned that this whole project is a scientific experiment. So in order to approach it in a scientific way, there have to be some variables that we can control for. And one of those things that we needed to know for sure is the type of sand that we were using, or the sand that was actually being produced from that crushed glass. And this is where Medalla Light came into the project, because we needed to know 100% for sure that the bottles that we would be crushing were going to be composed of the minerals that we would find in the Caribbean. So glass is created from sand, and that sand is going to be taken from the natural area where that bottle manufacturer is located. So for us, we needed to know that the bottles were actually made in the Caribbean. It didn't have to be Puerto Rico, but it needed to be our region. And Medalla was very transparent with us and really excited about this project and excited to get involved. So they introduced us to their supply chain, where we actually got to speak directly with their bottle manufacturer to find out that their bottles are made in the Mexican Caribbean, so same latitude as us, and composed of 99% silica. And that's important because marine organisms use silica to create their skeletons. And so once we knew this, then we had essentially our foundation for what we could then move forward with this idea of using crushed glass sand, or that RGS, for coral restoration. And this allowed us now to be able to control that variable in the experiment. So from essentially what we've done now, I get a lot of questions about this from people want to know if we can use other types of bottles. That would be something we would like to test in the future. But for now, since we have to keep things controlled and for this experiment, we're only using the Medalla Light bottles, since those are the only ones that we can confirm 100% where they're being made. Okay, so the method involves using this machine that you see over on the right, and I'll be following this up with a video so you can kind of see how it works. But it's a bottle crushing machine that we purchased from the company Expleco in New Zealand and had it shipped here. They now have a US distributor as well, so that makes it a little bit easier for people in our region to get this machine. It's very, very simple. There is one on-off switch and one red button that you press to turn it on. But essentially what happens is the bottle is placed into the top and to the neck of that machine. It's crushed in the center, and that fine grained sand falls into that 5-gallon bucket at the bottom. So we collected these Medalla beer bottles from our friends and our family because again, since it's a pilot project, we didn't need a ton of bottles. We just needed enough to help us address this question. Those bottles were then crushed in the machine to produce that fine grained sand. And then we used that RGS with cement and marmalina, which is our traditional mix for coral restoration. And we came up with different proportions of those 3 ingredients because the point here was for us to see if we could introduce a high percentage of RGS without altering the properties of the cement as an adhesive. So in coral restoration, it's really unique that we can use cement to act, and yes, it does work underwater, but we could use that to plant the corals to the reef. Traditionally, that mixture is composed of a ratio of cement and marmalina, which is basically crushed marble sand, which helps with that adhesive property and the hardening of the cement. So essentially what we were trying to do is to replace some of that cement and marmalina with this RGS sand and see if we can essentially accomplish the same result. We then took our mix and we are going to be planting 300 corals of the Elkhorn species, the one I showed in the picture earlier, along the south coast. So far, we've planted 200 of those 300, and next week we'll be going out to finish by planting our last 100. So we've set this up with 2 experimental mixes. So that's 2 different ratios of RGS and the other components, and then 1 mix, which is our control. So because it's a science experiment, we have to have something to compare the experimental mixtures to. So we also planted 25 corals out of our 100 with our original just cement and marmalina. So that'll help us to know if there's any differences in our experimental mixes compared to our traditional mix. And then these corals are going to be monitored for an entire year. And when I say monitored, I mean we're going to return to these corals and we're going to continue to measure their growth and to look at their health, to observe if any of them have died, if any of them have become diseased or have bleached, and also just to measure to see how quickly and how well they're growing. Okay, so this is an example of basically dropping the bottles into the machine. And you can put the bottles into the machine with the labels on as long as they are not metallic labels. So some beer bottles have a metallic sticker as the label. You have to pull that label off if you use that particular brand. The Medalla bottles, that's not the case. So you can put them in with the labels on, and then you can remove the labels afterwards, which I'll show you in the next video. For us, because we just didn't want to introduce any potential chemicals from the inks or anything on the labels, we actually removed the labels from the bottles for the ones we were using for our experimental mixtures. And then afterwards, it produces the sand. And the particles, of course, are various sizes. So we have to sieve it here because we're interested in the smallest particles and essentially also that powder that's being produced. And you'll notice what's left are just like the bigger pieces of glass and the paper from the labels. And then what's below is just that really fine powder. And then the next thing that we did, this is the HDR Reefscaping team. This is us testing out our ratios. So each of these guys has a ratio of the RGS and the cement and marmalina. For instance, like 2 cement, 1 marmalina, 1 RGS, or 1 cement, 1 marmalina, 2 RGS, for example. And they're mixing up those mixtures here, and then they're going to place them in the water so that we can observe how well they harden. Now, the water we're using is seawater because that is what we would be using in the field. And the water that he's about to place this example into is also seawater. And this is really cool. The first time I did this, it kind of blew my mind that you can use cement underwater like this and it does harden. It's really impressive. And then this is essentially what it looks like once we get it out into the field. So this is from our first planting of 100 corals. So you'll see that that's basically what it's like. You take a handful of cement. The tag there just helps us understand which mixture is being used for these fragments. And those are the small pieces of elkhorn that were clipped from the coral nursery. And if you look close, you can see like little kind of like shimmers of glass pieces there in that cement. So those are the broken pieces of the crushed glass sand.
Sorry about that.
No problem. Okay, so then one way that we can observe the growth of the corals over time is using a orthomosaic or like a photo mosaic. And how we produced this is by using a camera and taking a series of images and then using a program that stitches those images together to create essentially what we have is like an aerial shot. So it's kind of like flying a drone over the reef and getting this really clear image of what the bottom of the reef looks like. So this is underwater, what you see on the left and the right. On the left, it's the area that we had chosen to do the restoration, where there's not any coral growing now, but there was in the past. So what you're seeing there, all that brown, is basically rock and sand. And the squares, the black and white squares, are just there to help us orient the photos. On the right is now what you see as the tiny little fragments of corals that have been planted. So the red numbers just indicate the number of the fragment. And then I've included this yellow circle to just show you that there's a clump of 25 that belong to tag number, it looks like 57. And that tag is just going to indicate what mixture we were using for those particular set of 25 corals. And we repeated this again with the 100 corals that we just planted this past week. And we'll do this with the next 100 that we plant next week. So we'll be able to go back and do the same kind of imagery with each time that we monitor, so that we can kind of observe in a visual way how all of the corals are growing together. So this is essentially like our plan for this project. Since it is a pilot project, we were only planning to really do it for about a year. We started our campaign with Medalla in April. So we started kind of like reaching out to them and working with them to kind of get this project off the ground then. In June is when we planted our first 100 fragments. September is when we're going to be planting 200 more. So we'll finish that up next week. And then from December, February, and April, we're going to be going back and monitoring the growth of these corals. So corals do grow very slowly. However, the Elkhorn coral is one of the faster growing species. So within a year, we'll be able to see very noticeable growth that will allow us to answer this question on whether or not this cement mixture was useful for this process or not. So we're anticipating that the project will then essentially finish in August or September of next year. And then by December, we'll have all of our results and everything finished and ready to present to anyone that's interested. Okay, so then what we're essentially expecting, we have two hypotheses here. One is that the mix of the RGS will work in the same way as traditional cement, and then it's not going to present any problems with adherence or essentially that hardening process. We were already able to see that this was true, but it didn't work for all of the ratios. So we did find a ratio of RGS where we added too much, and it actually did mess up the properties of the cement, and so we did not use that mix to plant the corals. The second hypothesis is that we believe that the planted corals using our RGS mixtures aren't going to show any difference in their growth rates compared to the original mixture. So we are anticipating that everything's going to grow exactly like how it does with our just cement and marmalina mixture. But one thing we would be interested in seeing, and we kind of think this could be potential, is maybe the growth rate will actually be a little faster because we've introduced that addition of silica, which the corals naturally use to create their skeletons. So we're interested to see if maybe the growth rate is a little bit faster than the original mix. And this is essentially what we're going to be looking for over time. So see, this tag is old. This is within the same area, but this coral was grown from a fragment that was planted, I believe, a little bit over 5 years ago. The diver is just showing you like how well this has grown within that time. And as the diver starts to pull away from the bottom, you'll notice that there are other corals that are about this size in the area. And all of those have been grown in the same way that that one was. So those were all planted as part of a coral reef restoration process. So that is wonderful success. And we are anticipating that we will see the same thing with the ones that we are growing now. So besides just doing the experiment, we're also planting them in an area that needed to be restored in the first place. So our next step and our plans for the future, once we have our results, we're hoping that we can kind of expand on this in some ways. One thing that we think would be really interesting is if we can get some of our local municipalities to get behind this idea of crushing glass bottles to make sand and find unique ways that we can use that sand. The company that we bought our machine from does make industrial sized machines, bottle crushing machines. So it is possible for municipalities to have this kind of infrastructure. And so maybe this is a discussion that we're hoping we can maybe have with a few municipalities around the island to see if this is a feasible plan. We also plan to use RGS for other conservation projects. Like I said, since we're independent, we've got a lot of flexibility to get really creative with our project ideas. So we've got a lot of other things in the works and with our wheels turning on how we can continue to use this with our own projects. We know that there's folks in the US Virgin Islands that are using RGS to create sandbags to help their residents prepare for hurricanes. So that potentially could be something we could do here. RGS can also be used by cement companies to create their own blocks or to create other types of products. This is not new. RGS has been used to create like cement type products in other parts of the country of the US. So this isn't a new idea, but it might be a new idea for us here on the island. And then we're hoping that maybe we would be able to produce RGS for the other coral restoration practitioners here around the island. There's folks in the north and in the east that are doing the same things that we're doing. So it'd be great if we find that this works really well, that we can produce some more sand and be able to pass that around to the other practitioners in the area. If you're interested in following along with this project, you can find, I'm going to be like blogging about it and sharing pictures and videos and things and keeping people updated on the project. So if you visit our website, islamarexp.com, and click on the news section, that's where you'll find all of our news related to any project that we have going on. Once you get to our homepage, you can also sign up for our mailing list where you can get noticed when I post news about this project. Medalla Light also has some pretty cool things on their website. You can find all of the videos that they produced and with their campaign to kind of help us spread this message. That's at medallalight.com/corales. And you'll also see too, they've partnered with Con Calma and have created some pretty unique bags and hip packs that the purchase of those items, the profits from that are actually going to be going to Isla Mar, us, and to Reefscaping to help us fund additional coral restoration and monitoring efforts around the island, which is great because this is a really useful program, like doing coral reef restoration that a lot of times is not very well funded. So it's amazing, and we're extremely grateful for this kind of a partnership. So if you're interested in helping out in that way, definitely check out the different things that they have on their website. And then if you want to learn more about our partner, HDR Reefscaping, visit their website too, because they also have some really cool projects that are different from what Isla Mar is doing. And then here's our contact information. This is the end of my talk, so I'm happy to answer some questions, but if I don't get to everybody's, then please feel free to email me at islamarexp@gmail.com, and you can visit us on Facebook at Isla Mar PR. And with that, Carla, I'm going to turn it over to you to see if there's any questions, and I appreciate you guys with your time, and thank you for listening.
Thank you so much, Chelsea, for all the information. It's a great project, what you're doing, so thanks for sharing that with us. No sé si alguien tiene alguna pregunta que quiera hacer o que quiera escribir por el chat como tal, puede hacerla directamente también a Chelsea. ¿Tienen alguna curiosidad, algo que quieran saber sobre el proyecto?
Yeah, you can ask anything. It doesn't necessarily have to be about the project either if you're just curious about what Isla Mar does.
Fernando says, very thankful that you are running this project.
Oh, thank you. We're hoping that we can scale it up in some ways afterwards, or that we're also hoping that it might inspire other people to come up with really unique and creative ways to kind of work with other materials for conservation type purposes. And we have seen that so far. We have some people have reached out to us wanting to know like how they could potentially use RGS. So it's neat. It has sparked a really good conversation.
Yes. Fernando also says we are planning a group at Goico in Calle Loíza.
Oh, okay. I'm not familiar with Goico,
Escucha.
but
Sí, te escuchamos, Fernando.
Hi, how are you? I'm Fernando. Goico is a school that got turned into a community center, and they have something called Machuchal Limpio, which is the roots beginning of a recycling program. Just yesterday, just Tuesday night, we were getting together a glass pickup place
oh, that's great.
to move things over to Bloques
Uh-huh.
Caribe. Bloques Caribe is taking glass to make their blocks.
That's great. Wonderful. That's awesome. Thank you for sharing that with me.
Yeah, I'll get in touch with you later to see how we can collaborate.
Sure. Yes, please do.
Generate some traction to get together with other people to make it bigger.
Wonderful. Yeah. Thank you.
Thank you, Fernando. Thanks for sharing that. No, wait,
I
we
wanted
have
to ask a quick question.
Sure, Jesus.
Hi. I'm actually working with Fernando in Lagoico, so we're part of the same team, Machuchal Limpio. So we're starting to try the pilot project to just gather as much glass as possible from the community and transfer it to Bloques Caribe, which is the only place that we know of that accepts all types of glass. We were discussing with Fernando maybe acquiring one of these machines that actually processes the glass and turns it into sand.
Mm-hmm.
Have you identified any sort of funds or anything that might help us gather the money or maybe secure any sort of funding in order to kickstart this project?
Well, so like originally what we were trying to do, we had actually had a much larger experimental project that we had designed and developed and submitted to a particular NOAA grant to fund this project. And when we had reached out to Medalla for that, we had just asked them to essentially provide like a letter of support saying that they, were supportive of what we were doing and that they would help us get the information that we needed about the bottles themselves. And they had asked us, keep us updated though, if you don't get that grant, we still want to know. We didn't end up getting the grant. So I went back to them and they're like, well, we'll just fund your project at a smaller scale anyways, because we're really interested in what you're doing. So like, let's just go for it. And so we kind of turned our project into like a much smaller version of what we had intended to do. And that's how we secured the funding to get the machine. So Medalla sponsored us in that sense. So they provided those funds to get that machine. So maybe there would be a local business that would be interested in kind of branching into ocean conservation or any kind of environmental conservation, and sort of that's like a way for them to kind of get their feet wet in that sense. So maybe there would be like a local business that would like to sponsor you guys in that way and help get you the funds to get that machine. I can say, if you email me, I can send you the specifications as well as the contact information for the US distributor. The machine with tax and with shipping was a little less than $7,000, just for reference.
Perfect. That's actually quite great because we have a lot of local businesses surrounding Lagoico, and there's also a brewery called Vivo Beach Club that's a little bit way off in Piñones. So we could definitely maybe reach out to Vivo Beach Club and see if they would be interested.
Definitely. Or if, and if they come back and say like, well, maybe maybe you can get a couple of businesses, 3 or 4 businesses all together that can contribute to get you guys that. But yeah, it could be a unique outlet to go that way. That was really new for us. We had never really tried that with our scientific research, but it's been very fulfilling and a really unique and exciting partnership to like be able to team up with a business and to see them get behind like in our case, marine conservation. It's been really exciting to see Medalla Light take that stance. So it's like we're hoping that this will continue to grow into new and exciting things. So hopefully that will be the same experience that you have as well.
Thanks.
Let me ask a quick question. How many bottles can you process with your machine per hour or like per day?
It depends on how long you want to sit there, because you see, like, you're the one that's essentially putting it in there.
Right.
I think like our team basically turned it into an afternoon, just a relaxing afternoon. And
Right.
as they drank a beer, they'd put the bottle into the machine, there is a limit on the number of bottles that can be produced with, or the sand that can be produced with the bottles with the filter screen that's in the machine. So you do have to change that out. I don't know the number off the top of my head, but it is in the specification sheet. If you're interested, I can pass that information along.
Appreciate it. So it's like a community thing, right? People can come in and help and putting some time in and then turn glass into sand and then have it ready to be used in other things.
Yeah, sure.
Thank you.
Thank you, Fernando and Jesus. We also have another question here. Let me see if I can find it. Laura Almodovar, she was asking, you might have mentioned this, but approximately how many bottles are used to build the reefs?
Oh, okay. So we're gonna have those figures by the time that we finish the project, because it varies a little bit with the mix that we're using. So once we know which one is essentially the winner, then we can provide that information. So I would say check back with me in September, October next year, and we'll have those results. We would probably even know that somewhat before that timeline, but yeah, right now I can't quite say, because we're not sure really which one's going to end up being the winner. But yeah, we will be able to provide that information.
Thank you, Chelsea. Carmen also says, interesting, this project will help also in recycling glass bottles.
Yeah, absolutely. That was kind of where we were going with it, really. Since recycling glass in general, no matter where you are, is expensive. So a lot of cities don't do it. So that's kind of what we were hoping. And other Caribbean islands actually have other unique ways that they can deal with that, like buyback programs, where they companies will buy the glass bottles back from them and then clean and sterilize them and reuse them again. That would be a cool solution for us here too, since we have really limited space in our landfills. But yeah, that was essentially what sparked this whole idea, was in what ways can we recycle or repurpose our glass waste? And this was what we came up with.
Thank you, Chelsea. Rosalina has a question. I'm not sure if I'm gonna translate this well, but she says in Virgen Gorda, the breeding island, they use the glass to add it to the beach, to the sand on the beaches. And she asked if we can do that here in Puerto Rico.
Oh, okay. So they're using, they're basically taking that sand and re-nourishing the beaches. That would be something that we would have to look a little bit closer into, because as that does sound simple, right? And it sounds like that should be very easy to do. Beach renourishment projects do take a little bit of background knowledge about what's living in the sand on the beaches, because that's actually a whole ecosystem of its own. At least from my experience living in Florida, and with Florida doing beach renourishment, what we've come to know is that those are not always successful, because the sand that gets put onto the beach is of a different composition than the sand is naturally there. And we're talking particle size, the material itself. And so the organisms that live in the sand have a hard time adapting to that. So that would be something that we would have to investigate to see how different the sand that's produced from RGS would be compared to the sand that we have on the beach here. So since I told you in terms of the minerals, we know what the minerals are, but the grain sizes, it's a little bit trickier than just simply doing that and putting the sand on the beach. But I will say though that the sand itself, it's not sharp. So like you can pick up, like you could go scoop a handful of that sand from like the video that I was showing you, and you're not getting cut by that. It's very smooth and soft. You really wouldn't know probably that it is made from the glass bottles. In our case, you could see it in the video just because it's being mixed with that cement, so some of those particles stand out more. But yeah, in terms of beach renourishment, that would be something that we would have to research that before we just went and did that.
Awesome.
I hope that answers the question.
Yeah, yeah, it definitely does. So I don't know if anyone else has any question they want to ask Chelsea directly. I was wondering, are you going to work later only with the Elkhorn Coral, or are you planning to do the same thing with other species of corals?
The Elkhorn Coral, and then its like sister species, the Staghorn Coral, those are the two that predominantly are used in coral reef restoration, because for a couple reasons. One, they're like hardier species, so you can handle them more like without injuring them or harming them, and they also grow faster than many of the other species, so that makes them really good candidates for coral reef restoration. So I mean, not to mention too, they're also two of the actual like reef building corals. So they're hard corals that create like the three-dimensional structure on the reef, which is what is really useful in protecting the coastlines from erosion and from damaging like swells and flooding. And it's also that three-dimensional structure that creates homes for fish and for other organisms. So traditionally, those two species, like the Elkhorn and the Staghorn, are the, like kind of the more popular ones used for restoration. There are others, and there's even other types of restoration that are ongoing here in Puerto Rico, besides just like what I showed you here tonight, that are using different species. They're just a little bit slower growing. So like for our purpose, we needed to use something that would be fast, that we could kind of, for like the experimental aspect of it, that we could be able to determine and see fast visible growth within a year.
That's great. Can you envision on a future doing the same project all over the island?
I mean, that would be amazing. Like that's one way that we would love to see this get scaled up. As long as it works well, then yeah, like it's the hard part though is producing that sand does require some time, and we certainly wouldn't be able to produce enough to help everyone do this kind of work, but I think we could at least get to a point where we can help supply other practitioners that are within like our network that are doing this kind of work with that sand. But we're hoping that this really serves as like a jumping off point for other people to get creative and to come up with unique ways that we can use this sand in other ways, like besides just coral reef restoration. But we'll see how it goes. Like coral restoration is something that's ongoing around the island with several other teams and other people that are working, I mean, even in Celebración and Vieques and the north and in the east. And, we kind of tackle the west and the south. But yeah, like there's many people that are doing this work like all year round. So yeah, if we have the opportunity to be able to scale this up, then we certainly hope that we'll be able to do so.
You can definitely count us in. So we'll follow your work, and we'll definitely see what happens. So thank you very much, Chelsea, for being
awesome.
With us
thank you
tonight. And to everyone that connected with us tonight, thank you so much. I don't know if all the attendees here can like turn on their camera so we can take a picture. So I'm gonna stop the Facebook live here and the recording so we can take a picture.